Hello everyone. In this video I will show you how can you get answers from multiple files, which means that you will be asking one question and your answer could be any of the files which you are taking as an input. So here we will be using OpenAI, TikToken and Python. So let's get started. First of all, we need to import all the required packages. So let's go ahead and say import pandas. Then we need to import NumPy. Next we need to import OS because we need to deal with local file systems. And then I would say import TikToken, import OpenAI. So these are the ones, and next one is the configuration from which I am reading my OpenAI key. So let's set that as well. OpenAI dot API key equal to configuration. You can read it from anywhere. In my case, I'm storing it in a configuration file. Then here itself I will go ahead and set encoding. So ticktoken dot get encoding, and inside this I will be using CL100K base. So these are the initial things which we need. Next thing what we are going to do, we are going to construct a data frame which will primarily have three columns: file name, content and the number of tokens which are used by that particular file. So for that we need to go ahead and construct the data frame. So I am naming that as df, and here we will quickly say what all columns we need. So first one would be file name, second column is the content which is sitting in that file, and the third one is tokens. So once these columns are constructed, we need to browse the directory or the path wherein we can read all the files. So for simplicity purpose, here I am taking all the files as text file. So let's go ahead and read those. So for reading the files inside from the directory, I would say list dir, and inside that I will be passing the directory name. So for me it is data store. You can pass the directory whatever is present on your machine. And inside this file name, now we will say if file name dot ends with txt, then go ahead and open that file. So let me quickly provide its path again. So it is data store, and then I need the file name. So this should go, and let's name it as F. So here we are getting individual files and then we are extracting the content out of that. So I will call it as lines and we'll say f.read lines. Okay. So this is reading line, and then what we need is we need to know how many tokens individual file is using or the row of your data frame is using. So I would say token equal to encoding dot encode. So note that we have already set the encoding here, so I'm not setting it again, and I will simply say join because this is going to return list. So here we will get tokens. Next thing is we just need to push this data into our data frame. So for that we can call append, and it's just like key value pair we need to define here. So let me quickly type this. File name I want, and its value would be the file name which we extracted above. Then we have content column whose value is the same thing. I would have calculated it above, but it's okay, let's go with this way. And the last column we have is tokens, and its value is nothing but the length of tokens. Okay, once this is done, we need to pass additional parameter ignore index, because if we are not doing this, append will throw you an error. I believe this should work. Let's go ahead and print the data frame. Okay, so here you can see this part, you can see. So file name is coming as empty. It means we missed something with open data store double slash. Okay, so there was a typo problem with this column name. Let's run it. And now you can see that two rows got added because I was having two files. So this is a file name and this is its content, and these are the number of tokens which are used by this particular file. Similarly, I have a sports file, then I have this content, and these are the number of tokens which are used by this particular file. Okay, so once we are done with this thing, next thing we need to do is we need to, let me remove this. Okay, so we need to calculate the embedding. So for that, I'm going to define a function. So there is nothing fancy in this. This is the same function which I have explained in my previous video. So I'm just going to type it here. So here you can define what type of embedding model. So I would say embedding ADA002, and it's going to return us a list of float because embeddings are the values which are in float. So let's quickly go ahead and call the create endpoint for the embedding. I would say OpenAI dot embedding, and then I would say create. So inside that we can say model equal to model. Input we can say as text, which is passed as a parameter. And once this is done, we will simply say return me the result. Now this result will be in the form of some hierarchy. So if you're not sure why I'm doing this, either you can go through my previous videos, or you can go through OpenAI documentation, which will tell you what is the response format. So inside data at the first level, we will be having embedding. So this is how you can go ahead and figure it out. Okay, so once we got the embedding, we need to compute this particular thing for all the rows. So how we can do it, we need to iterate through it. So let me quickly write another function, compute doc embedding, which will take data frame, and it is of type pandas data frame. Then let's go with this one first, and then we need to say return row. This is kind of the same syntax, so rather than explaining, I'm just typing ahead. Get embedding, and this embedding we need to call on content column of your data frame. Okay, it's not taking. Let me go ahead and type it. For row index row in df dot iter rows. Okay, here it is, and we need to put these brackets. Okay, so this function, what it is going to do is going to call embedding on all the rows for the content column, and let me define its return type. It would be easy for us, so let's call it dictionary, and inside this we will have str, and then we have a list of float values. So, and I need to define colon over here, and we are good to go. So once this is done, we are done with computing with our embedding computation. Next thing is we need to compare the documents. So for that, let me go ahead and create another function, which is order document section by query similarity. So here again, this is the same function which we have written earlier also. So what it is going to take, it is going to take the query which user wants to execute. Then we will have context which is nothing but the dictionary of string. And next thing would be the array. I will explain you when we will execute this. Let me quickly type it first, and then it is going to say query embedding, and here we are going to calculate the embedding for the query which is supplied by the user. So this is the first thing. Then we need to figure out the similarity between the user's query and the embedding which we have in our for our documents. So for that we need to say dot product, calculate the dot product here, and I'm going to say document underscore similarities, and this we want in the sorted form because we want the highest rank to come on top. So that's why I'm doing. If you're not using sorted or reverse equal to true, in that case you have to sort it by yourself. So let's go ahead with this one, and here I'm saying the dot product. So np dot array. First of all we will pass the query embedding, and then we will say document embedding. So here we will say doc embeddings. This is done, and next thing is the doc index. So I would say, let me see if I'm missing something. So what this is doing, it is calculating the dot product of this one, and then we are dot product is calculated for query embedding as well as the document embedding. So once this thing is done, then we need to do this calculation for all the rows. So here we need to put loop again. So I'm using for doc embedding. Let me give it different name, otherwise it would be very confusing. So here it would be doc embedding in contexts dot items. Okay, and here we have this bracket, and at the end, like I said, we need the highest rank to be on the first position. So let's make it a reverse equal to true. So I guess we are done. The only thing which is remaining is the return type for this function. So let's define it float again, because embeddings would be in the float form, in the float data type, and here str comma str. Let's execute this. We are missing something. Okay. Okay, so let me quickly execute this and see if we have any errors. Okay, so here we need to return one more thing, which is similarities. Control C. Okay, so we are done with our all the groundwork. Next thing is we need to use our actual query to figure out what are the similar ones. So I'm going to call this function here order sections, document sections by query similarity, and it is going to take your user query. So let me type in something. How poverty is the reason for homelessness. So let's go ahead and figure out the answer of this query based on the two documents which we have supplied. And here I'm saying compute doc embeddings, which is going to take data frame as a parameter, and I'm interested only in top two results, but let's say you have many documents, so you can define those numbers. So let's say you are interested in all the initial 100 top ranked portions of your documents or the documents. So in that case you can define that number. Here I have taken just two documents, so I think for me in any case I will not get more than two. So that's the reason I'm doing it. And so let me go ahead and print this out, run it, and oops. So Let's do it once again. Okay, we are good this time. Okay, so now you can see that for this particular question, there were two documents, and the first document was ranked with 88% and this is 68%. So there are high chances that my response will be in this particular document. So let me go ahead and utilize the same index and the values to figure out what is going on. Now we are using here GPT 3.5 Turbo, so which means that I need to define here roles. So let's type in here. So the first role is system, and here content would be, let's say I am saying you are a professor who provides to the point answers. So you are a professor who provides to the point answers. So what are we question we are asking? We are expecting this particular system to behave like a professor and then provide us the responses. And then next thing we need is the user text. So for user text, we will be utilizing this particular response here. So in my case, I can say content is my column, and then we have similar ones, 0 comma 1, because I need to read this particular value here. So this is falling on the 1 index or the second position. Okay, so once this is done, we will go ahead and append this. So this would be my query now. Let me grab this query from here. This would be the query, and this we need to append with user text, which we just calculated above. Okay, so along with this query, we are going to pass this particular thing because this is what we have the context. We want this question to be answered from this particular given user text. So that's what we are doing here. And once this is done, we need to append the message. So messages dot messages dot append, because initially we defined the role for the system. Now we need to define for the user. So here we need to again say role, and this time this is user role. Content would be the user drafted content, which is this thing. Okay, so we are done with system level, we are done with user level messages. The only thing which is remaining is to call the chat completion endpoint, and that we can do it using OpenAI dot chat completion dot create. And inside this we need to pass our model, which is GPT 3.5 Turbo, and of course we need to pass in messages here. So we are done with this. Let me extract the response here. So I would say reply equal to response dot. So again, if you are not sure why I am doing response dot choices, this is the format of the response which we get from the completion API, and you can read about this in the documentation also. So let's do this and go ahead and print this. Okay, so if everything is fine, we should get the response. Oops. So it is saying none of the index are an index. So perhaps we did some mistake here. Oops. So instead of closing here, we are supposed to put the square bracket here. Okay, so this is our response. Let me quickly paste it here so that we can read it. Okay, so the question was how poverty is the reason for homelessness. And you can see that I just took two documents as an input. First one was sports and second one was homelessness. So definitely this answer should be from the first document. So poverty is the major contributing factor to homelessness. When a person lacks the resource to maintain a decent standard of living, they may be forced to prioritize based their needs based such as food, healthcare. So all these things are available in my document, and that's why we are getting this response. So I hope you got an idea how you can do this, and there are a few things which I didn't cover here in order to keep it simple. So the first thing is, let me quickly print this data frame here. So you can see that in my case, tokens are pretty less. So if you're taking the file which is really very huge, then in that case you have to divide this content into multiple rows so that your number of tokens would be pretty less. So this is the one thing which I have not covered in this. And next thing is, if you want this conversation to keep on going, then in that case you have to put it inside a loop and keep appending the messages. So that's how you can set the context for the next question. I hope you enjoyed watching this video, and make sure to give me thumbs up and subscribe to my channel. Thanks for watching.